Yeah. Good afternoon once again, children. It's now good afternoon, children. Yeah. So let's start with recalling the standard form of a linear equation in two variables x and y. I want you to tell me the standard form of a linear equation, not a pair, of a linear equation. Standard form of a linear equation in two variables x and y. Yes, with the conditions. Yeah. I've shared my screen, children. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yeah, children. Yeah, standard form of a linear equation in two variables x and y. Yes. Go down to 9th standard and recall from the depth of your memory.
Ma'am, ax plus by plus c is equal to 0.
Perfect. Ax plus by plus c is equal to 0 is the standard form of a linear equation in two variables x and y. And what about the conditions, Raja? A, B, C can be?
Any integer.
No, still broader. Then A cannot be 4 by 3. 4 by 3 is not an integer. So A
Any
cannot be
real
4 by
number.
3. So yeah, so A cannot be root 2. So A can be any real value. A, B, C are real numbers. Then one more important condition.
A is not equal to 0.
Ranjan, good. But it is A and B. Both should not be 0 at the same time. Because if A and B are both zeros, then you will not have the variables x and y. If A is 0 and B is 0, so then it will be 0x, 0y. So then you will lose the variables x and y. So both A and B should not be 0 at the same time. If A is 0, B should not be 0. See, it can be like this. Now, 3x plus 5 is equal to 0. You remember, we can treat, now you can see only one variable x here. But this one can be treated as a linear equation in two variables x and y. On the face of the equation, it looks like a linear equation on only one variable x. But this one can be treated as a linear equation on two variables x and y if you write it like this. So this is of the form ax plus by plus c is equal to 0, where a is 3, b is 0, and c is 5. So ax plus by plus c is equal to 0 is the standard form of a linear equation in two variables x and y. Conditions a, b, c, real numbers. Most important condition, a and b should not be both 0 at the same time. If a is 0, b should not be 0. If b is 0, a should not be 0. That is, you must have at least one variable. You should see at least one variable x or y in the equation. Because if x is there and y is not there, it's 0y. If there is y but no x, it is 0x. So there is, the absence can be brought with a 0x or a 0y. But if both x and y are not there, if it is 0x and 0y, then there are no variables at all. So then it is not a linear equation in two variables x and y. So a, b, c are real numbers, and that condition both a and b should not be 0 at the same time is written by a square plus b square should not be equal to 0. A square plus b square should not be equal to 0. Anyways, we are not going to understand this now. That's the meaning, which we've already discussed. So a square plus b square should not be equal to 0. Meaning a and b should not be both 0 at the same time. So this is about one standard form of a linear equation in two variables x and y. Now quickly tell me the standard form of a pair. Standard form of a pair of linear equations in two variables x and y. In two variables x and y. Yes. A pair. Two. Like what you said earlier. So one more. We just need one more.
ax1 plus by1 plus c is equal to 0 and ax2 plus by2 plus c is equal to 0.
Yeah, this is the most common mistake. I appreciate you came out with the answer, but just recall what you said and do the corrections. Okay, so from what you said, what are the variables, Danya? You said x1 and y1 in the first equation, and you said x2 and y2 in the second equation. So where are the variables x and y? So I'm sure you can correct it now. You said ax1 plus by1 plus c1 is equal to 0, and then ax2 plus by2 plus c2 is equal to 0. So your variable, I can see 4 variables, x1, y1, x2, y2. So I want only Danya to correct that. Yes, Danya. Let me write it so that it will be easier for you to. You said this. Or if you feel you're right, let's do it together. This is what you said. Our equations are x and y, not x1, y1, x2, y2. Anybody? Okay, Danya, no problem. Anybody else?
Ma'am, a1x b1y plus c1 is equal to 0. a1x b1 plus a2x b2y plus c2 is equal to 0.
Very good, Kirtana. Very good. Yeah. So it is the coefficients must be differentiated, not the variables. The variables are x and y in both the equations. The variables are x and y in both the equations. So what should be differentiated are the variables. That is the coefficients of x and y. They should be differentiated with different variables. Okay, so it is, see, it is this, let me tell you, it is ax plus by plus c is equal to 0. And again, ax plus by plus c is equal to 0. This is how we had understood when we saw this for the first time. So it is ax plus by plus c is equal to 0. But we want one more, right? So write it again, ax plus by plus c is equal to 0. Write it once again. Now, x and y are the variables. Don't do any changes to them. So it is a1, a2, b1, b2, c1, c2. a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. This represents the standard form of a pair of linear equations in two variables x and y. So again, conditions a1, b1, c1, a2, b2, c2 can be real numbers, any real number. Most important condition, a1 square plus b1 square should not be 0. a2 square plus b2 square should not be 0. a1 square, like we said here, no? A square plus b square should not be 0. Similarly here, a1 square plus b1 square should not be 0. a2 square plus b2 square should not be 0, meaning in the first equation, both a1 and b1 should not be 0 at the same time. In the second equation, both a2 and b2 should not be 0 at the same time. Is the meaning, is what is implied by these two conditions. Yeah. Quickly take a screenshot, children. Or you can take a photo using your phone. Yeah, done?
Yes, ma'am.
All right.
Done, ma'am.
All right. Yeah. So now coming to the graphical representation, we know that a linear equation in two variables x and y is given by a straight line in the Cartesian plane. So one linear equation in x and y, one straight line, two linear equations in x and y, two straight lines, and the two. So see, this is one linear equation in two variables x and y. So this is one straight line in the Cartesian plane. Here we have a pair of equations. So we have two straight lines. When you represent the equations graphically, we'll have two straight lines in the Cartesian plane, and the two straight lines can be coincident, or they may intersect or be parallel to one another. Are the three different cases. They may be coincident lines or parallel lines or intersecting lines. So we'll come back to this. We'll continue with this later when we revise linear equations. But I thought I'll just, we'll just recall this before we, understand parabolas. So that's what it is. So these are straight lines. All right. Now, standard form of this is the chapter polynomials, but since we have quadratic polynomials, we're just trying to recall, the standard form of a quadratic polynomial and quadratic equation. Yeah, now tell me the standard form of a quadratic polynomial in one variable x, in only one variable x. Standard form of a quadratic polynomial in one variable x.
Ma'am, ax squared plus bx plus c.
Very good. Ax square plus bx plus c. Ax square plus bx plus c is a standard form of a quadratic polynomial in one variable x. Condition ABC.
ABC belongs to real numbers and a is not equal to 0.
Very good. The coefficient of x square should not be 0. ABC, real numbers. The coefficient of x square, because x square is what makes this expression quadratic. The presence of x square is what makes this expression quadratic. So if a is 0, then it is 0x square. There is no x square at all. Then it will cease to be a quadratic polynomial, which is why the important condition here is that the coefficient of x square, that is a, should not be 0. Now, when you equate this quadratic polynomial to 0, it's called a quadratic equation. And yeah, tell me the quadratic formula. The quadratic formula. So we have different ways of solving a quadratic equation. We have different methods of solving a quadratic equation. You can solve it by splitting the middle term or by completing the square, which is deleted from your syllabus. Then you have the quadratic formula. So factorization, basically factorizing. You can factorize by splitting the middle term, or you can use formula, whatever factorization, and then by using the quadratic formula is all you know. All right. Yeah, is all we have in the syllabus. When I say all you know is what we have in the syllabus. Yeah, children, tell me the quadratic formula.
Minus b square plus or minus whole root of b minus 4ac by 2a.
Okay, so that expression gives you what?
Roots, ma'am.
Okay, so it's equal to what?
X.
X. It's equal to x. So x is equal to minus b plus or minus root of b square minus 4ac by 2a. By 2a. So this expression will help you to find the two roots of the quadratic equation. Now, what represents the discriminant here, or what is called the discriminant here?
b square minus 4ac.
B square minus 4ac or root b square minus 4ac?
B squared minus 4ac.
B square minus 4ac. Yeah, Prajit, you're right. So b square minus 4ac, where d is equal to b square minus 4ac. D is equal to b square minus 4ac, not root b square minus 4ac. So this can also be written as x is equal to minus b plus or minus root d by 2a. And we know that a quadratic equation can have no roots, may not have any roots, meaning the roots are imaginary, unreal roots. So the quadratic equation may not have roots, may not have real roots. When we say may not have roots, it has imaginary roots. So we say it does not have real roots. So may not have real roots, may have only one or two equal roots. When we say it has roots, their roots are real. When we say it has roots, that means real roots. We are talking only about real values. So it does not have roots, meaning no real roots, or one root, meaning two equal roots, or two roots, two distinct roots. Two roots meaning two distinct roots. anyone who's interested in taking a picture can take it. I'm going to switch the slide. So depending, b square minus 4ac is called the discriminant because this expression decides the nature of the roots of the equation. So that expression has the complete power over deciding the nature of the roots of the quadratic equation. So if the value of b square minus 4ac, you know, a, b, c are the coefficients. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. And you should always compare the given quadratic equation with this one, ax squared plus bx plus c is equal to 0. Don't change the sign. Supposing the quadratic equation given to you is like 3x squared minus 5x minus 5, don't write the standard form as ax squared minus bx minus c. The standard form is ax squared plus bx plus c is equal to 0. So on comparing, a is 3, b is minus 5, c is minus 5. So on comparing the given quadratic equation with the standard form, you can obtain the values of a, b, and c. And upon working b squared minus 4ac, so if b squared minus 4ac, the value is less than 0, that is it's negative. B squared minus 4ac is equal to 0. B squared minus 4ac is greater than 0. These are the three possibilities. So either b squared minus 4ac is negative, less than 0, positive, greater than 0, or it's equal to 0. The value of b squared minus 4ac is equal to 0. So in this case, imaginary or no real roots. No real roots. Here, equal roots. What is the other term for equal roots, children? Equal roots also called equal roots. Equal roots are also called coincident roots. Coincident roots. You need to remember these terms. Coincident roots. So in quadratic equation, they'll give you a quadratic meaning in that chapter. You're given a quadratic equation. Find the find the value of k if the equation has coincident roots. So you will be like, yeah, in that situation, it's easy to understand. When it's given coincident, it's easy to guess equal roots, right? Okay, so there can be a question like that. You're given a quadratic equation where, there's this missing factor k. So find the value or values of k for which the given quadratic equation will have coincident roots. Coincident roots meaning coincident roots meaning equal roots. Equal roots meaning d is equal to 0. So you'll have to work with that condition. D is equal to 0. B squared minus 4ac is equal to 0. So on working that, you can find the value or values of k. So b squared minus, so equal roots also called coincident roots. Meaning there's only one root, or we say it has two equal roots. And here, yeah, what is it when b squared minus 4ac is greater than 0? How do you call the roots? Sorry?
Distinct roots, ma'am. Two distinct roots.
Yeah, distinct roots or
Real and distinct.
no, real, we're not going to use that real. No, real is there. Okay, real is there. Real roots, equal roots, coincident roots. Okay, this one. Distinct roots. You found the second one. Okay. Unequal roots. Unequal roots or distinct. You gave me a very easy win. Distinct roots. Yeah. So equal roots, unequal roots in both the cases. Whether equal or unequal, real roots there. Equal, unequal, in both the cases, the roots are real. Only in the first case, no real roots. So second case, both the cases are real roots. Real equal roots, real unequal roots. So real equal roots are coincident roots. And real unequal roots are distinct roots. Distinct, two different roots. Coincident. The roots coincide. The coincident roots, distinct roots, unequal roots, equal roots. So remember these terms. Unequal, equal, easy to remember. Coincident, distinct, the terms are not new to you. The terms are, you're familiar with the terms, but you should remember in this context. Okay. So now when you when you make a graphical representation of a quadratic equation in one variable x, you get a curve, you get a smooth curve, again in the Cartesian plane, and that curve is called a parabola. That curve is called a parabola. Now the parabola behaves in a particular way depending on the value of, okay, it depends on few factors. We'll just see them with the help of the graphs here I have. Yeah. So the three cases we are going to discuss are these. We're going to see how the parabola behaves when the quadratic equation has no real roots. Okay. We're going to see how the parabola behaves in the Cartesian plane when the quadratic equation has no real roots. How the parabola behaves when the quadratic equation has two equal roots, and how the parabola behaves, meaning how it looks like in the Cartesian plane when the equation has two distinct roots. So these are three different cases. So the parabola always opens upwards. The parabola opens upwards if the value of a, which is the coefficient of x square, we have a x square, right? If this one is positive, the parabola opens upwards. If this one is negative, the parabola opens downwards. That's one thing. The parabola opens upwards if the value of a, which is the coefficient of x square, is positive. If a is, now the case that a 0 is not there, because 0x square meaning it's not a quadratic equation at all. So 0 is not possible. What if a 0 is not possible? So either a is negative or positive. Either a is negative or positive. If a is positive, it opens upwards. If a is negative, it opens downwards. That's one thing. And then the parabola just touches the x-axis in case of equal roots. It just touches the x-axis when it has equal roots. It intersects the x-axis when it has distinct roots or unequal roots. The parabola will not touch the x-axis when it has no roots, meaning when the quadratic equation has no roots. So this is how the parabola behaves. One behavior is opening upwards or downwards. When a is positive, it opens upwards. When a is negative, it opens downwards. That's one behavior. The other behavior is depending on the roots. If it has no roots, if the given quadratic equation has no roots at all, then the parabola is not going to touch or intersect the x-axis. It's going to be completely above or below the x-axis. It's going to be completely above the x-axis or completely below the x-axis when the given quadratic equation has no real roots. So the parabola will not connect with the x-axis if the quadratic equation has no real roots. The parabola will connect with the x-axis. Either it touches the x-axis or it intersects the x-axis when the quadratic equation has roots. So if the quadratic equation has one root or two equal roots, so one root, okay, it will only touch the x-axis because only one root, no, so it will only touch the x-axis. If the quadratic equation has two distinct roots, then the parabola will intersect the x-axis. It will cut the x-axis at two distinct points. So two roots, the parabola will cut the x-axis or intersect the x-axis at two distinct points. One root, it will only touch the x-axis. No roots, it will be high above the x-axis or below the x-axis. The parabola will not open left or right. It only, the mouth of the parabola will either open upwards or downwards, no left, right. All right. Yeah, so you just see the, now with this, look at the graphs. Yeah, I didn't tell you about the highest point of the parabola, mentioned everywhere. Okay. So this, this idea about the highest point in a parabola is not related to 10th standard, but case study questions, case study based questions have subdivisions where we need to have an idea about the highest point or the vertex of the parabola, which we have actually discussed, but we have not applied it in a case study question. So I think we'll see that today. So these, yeah, I had already shared some case study based questions with you as assignment sometime during the end of September, and then we couldn't discuss the answers to the same. So that's what we'll be seeing today. We'll be seeing them today after this, introduction part. Yeah, so now we're going to talk about the vertex of the parabola. So the vertex of the parabola can be the highest point or the lowest point, depending on how it opens. Now see here. Okay, so this one is called the vertex of the parabola. This one is called the vertex of the parabola. And the parabola cuts the x-axis. We are not concerned about where, we are concerned about where the parabola cuts the y-axis for a different reason. We'll see that. I'll tell you later. Now, okay, so that is when we have to decide the signs of ABC. You're given a quadratic equation and you have to decide. You're given a parabola, in fact, and you have to decide the signs for A, B, and C. That's where, where the parabola cuts the y-axis is important. But now what I'm telling you is, now this parabola, it opens downwards. So the value of A is negative. And the parabola intersects the x-axis at two distinct points. So clearly, the given quadratic equation has two unequal roots because it intersects the x-axis at two different points. So the quadratic equation has two unequal roots. It opens downwards. So the value of A in the quadratic equation, the value of A is negative. So the quadratic equation will be something like minus 3x squared plus whatever. So minus. Or it can be minus 3 by 5 also, whatever. Or minus root 2, whatever. X squared. But it's negative. But it is negative. Now talking about this point, which is called the vertex of the parabola. This point, which is called the vertex of the parabola. In this case, is the highest point. When the parabola opens like this, it is the lowest point. Then this is the lowest point. So the vertex is either the highest point or the lowest point. Okay, the vertex is either the highest point or the lowest point, depending on how the parabola opens, whether it opens upwards or downwards. Now the coordinates of this point is given by minus b by 2a, comma, minus d by 4a. Now this becomes important. So you will have to remember this. Now how you will see it on 11th standard, it's not a part of the teaching session for 10th standard. So since so the questions based on this are found in the case study based questions, we have to go into this. So this point, every point has an address, right? Every point on this parabola, every point is given by some address. Every point here is given by some address. Now this is called the vertex of the parabola. And the coordinates of the vertex is given by minus b by 2a, 2a, 4a. Denominators 2a, 4a, both negative. See, now you will wonder that the point is located in this case, the point is located in the first quadrant. Then how you say in the first quadrant, we know that the x coordinate and the y coordinate both are positive, right? So don't get confused. We'll understand them better. Okay, as we proceed, you will understand. Now the coordinates are given by minus b by 2a, comma, minus d by 4a. Both negative. Denominators 2a, 4a. Numerator b and d. Remember. B is not a capital B, you know that. And D is the discriminant here. D, discriminant. Minus B by 2A minus D by 4A are the coordinates of the vertex of the parabola. So whenever we say it is positive, greater than 0, we use greater than 0, negative, then less than 0. To say something is positive, we say greater than 0. To say something is negative, we say less than 0. Yeah. So case 1, when the polynomial is factorizable into two distinct linear factors. Two distinct linear factors meaning unequal roots, two different roots. So you can see that the parabola opens upwards when A is positive and it opens downwards when A is negative. And the coordinates of this point given by minus B by 2A, comma minus D by 4A. And it intersects the x-axis two distinct points because unequal roots. And you can see here, A is greater than 0, A is positive, A is less than 0, A is less than 0. It's very faint, but you can read it. It's very faint, but it is readable. A is less than 0, so opens downwards. A greater than 0, so opens upwards. Two distinct linear factors, so it intersects the x-axis at two distinct or different points. This is the highest point, this is the lowest point. Coordinates will be the same. Minus B by 2A, comma, minus D by 4. So that's what is here, children. That's what is here. This one is two equal factors. So you can see here the parabola intersects. There are three cases. Either it has no connection with the x-axis. It's up, it's above or below the x-axis. It doesn't connect with the x-axis, or it just touches, the parabola just touches the x-axis, or it intersects with the x-axis. So intersects two different points, so two distinct routes. Again, it opens upwards, or this is the second one, it opens upwards or downwards, depending on A positive or A negative. And here it touches the x-axis. See, here it touches the x-axis at exactly one point. That's because it has two unequal roots. Sorry, two equal roots. Coincident roots. And in this case, the y coordinate is 0. Why? Because now now this is minus D by 4A. But see here, since it touches the x-axis, the y coordinate for any point lying on the x-axis, the y coordinate is 0. And that's what it is. 0. For any point lying on the x-axis, the y coordinate is 0. The y coordinate is 0. See, here the vertex is here and here. So obviously this one cannot be 0. While here, since the vertex lies on the x-axis, the vertex is what touches the x-axis. So since the vertex lies on the, okay, the vertex is the only point that's common to the parabola and the x-axis. Vertex is the only point that's common to the parabola and the x-axis. So the y coordinate is 0. Y coordinate is 0. The x coordinate is minus b by 2a, like we saw here, minus b by 2. So it can open upwards or downwards. See, whether it has no roots, one root or two roots, the parabola will either open upwards or downwards. In all the three cases, the parabola will either open upwards or downwards depending on the value of a. If a is positive, that is a coefficient of x squared. If it's positive, upwards, negative, downwards. In all three cases, it can be upwards or downwards. Two roots, it will cut the x-axis at two different points. Vertex will not lie on the x-axis. And you can see the coordinates. Here, the vertex lies on the x-axis, so the y coordinate is 0. So it's minus b by 2a, comma 0. And you can see the description here that y is equal to ax square plus bx plus c. and a is greater than 0, a is less than 0. Y is equal to, because when you give different values for x, that is, if you give different values of x here, different values of x, you'll find the corresponding value of y on the y meaning on the y-axis. That's what is this y is equal to. Y is equal to. When you give different values for x, you'll find the corresponding values of y. So y is equal to ax square plus bx plus c. So here, not factorizable, meaning no real roots. So it's up, or it doesn't connect with the x-axis. It's above or below. But then we have the vertex. We do have the coordinates of the vertex, minus b by 2a minus d by 4a. Oh, sorry. While typing, I've made a mistake, children. I'm sorry, there's a typing error. Sorry. Please correct this, okay? I've shared the slides. Please correct this. The coordinates of the vertex of the parabola y is equal to ax square plus bx plus c are minus b by 2a, comma minus d by 4a. Please correct this, children. All right. Yeah, the parabola is symmetric. This is the line of symmetry. This is the line of symmetry. So the parabola is said to be symmetric above this axis. And this is called the line of symmetry of the parabola. Line of axis or line of symmetry. It's called the principal axis, whatever. Axis of the parabola or line of symmetry. Okay. Yeah, these are fine. The first one is quadratic, the second one is linear. Yeah. Now coming to identify. Okay, maybe you can take pictures of these children. Nothing. This is very simple for you now. At the moment, it's very simple. Having learned so much from polynomials, this is very simple. You can just take a picture if you want. You just have to say if it is linear or quadratic. So what you see now, the first one is neither linear nor quadratic, because the graph cuts the x-axis at 3 distinct points. So this one is a graph of a cubic polynomial. You can see that the graph cuts the x-axis, not y-axis. We're not worried about that. The graph cuts the x-axis at 3 distinct points. So this one is a graph of a cubic polynomial. This one is a parabola. So it is this one corresponds to the fourth graph, meaning this graph, the second graph corresponds to a quadratic polynomial. This one neither corresponds to a linear polynomial nor a quadratic polynomial. Yeah. Now here a graph is given to you. I'll share these images on WhatsApp later. So here we have a graph, and we need to identify the signs of A, B, and C from the graph. Now we'll understand all this in words, meaning here it's all symbolic. No, see, minus b by 2a is greater than 0, meaning it's positive. This one meaning it's negative. It's negative, positive. So I'll use the terms positive, negative. Let's understand. And then when you write, you can use, when it's positive, you can use greater than 0. And when it's negative, you can say less than 0. But I'll not explain using these inequalities. Yeah. So what I'm saying corresponds to this one here, corresponds to this explanation, whatever you see on the screen. But when it's greater than 0, I'll be saying positive. When it's less than 0, I'll say negative. All right. Yeah. So we need to identify the values of A, B, and C. A, B, and C. Now, A is easy to identify because the parabola opens downwards. So the value of A is negative. The value of A is negative. A is some value, but it's negative. So that's what is here. A less than 0. A less than 0. Now to find the value of B, not the value of B, sorry, to find the sign. Okay, the sign B carries. We use the x coordinate of the vertex of the parabola. We use the x because there is B there. And we know A. We know A, right? We know the sign carried by A. So using that, we can determine the sign carried by B. All right. So we're going to use the x coordinate of the vertex of the parabola to decide or to determine, to judge the sign carried by B. All right. Now, minus B by 2A. Minus B by 2A. That is the x coordinate of the vertex. In this graph, the vertex lies in the first quadrant. The vertex can lie in any quadrant depending on how the graph is. Okay. In this graph, the vertex lies in the first quadrant. And we know that both the x coordinate and the y coordinate in the first quadrant are positive, are both positive. So minus B by 2A, which is the x coordinate of the vertex, is positive. In fact, both are positive. Positive, positive. So minus B by 2A is positive. That means it's greater than 0. Because it lies in the first quadrant. So it is positive. Now, when you change the signs on both the sides, children, when you change signs on both the sides, see now, minus 4 is greater than minus 10. Is this correct? Is this correct? Minus 4 is greater than minus 10. Is this right?
Yes, ma'am.
Yeah, minus 4 is greater than. Yeah, you need to take a second think and then, yeah, minus 4 is greater than minus 10. Now, let's just remove the signs on both the sides. Okay, is it still true?
No, ma'am.
No, it's not true. So it's not an equation. It's not an equation that you can cancel the minus on both the sides. It's an inequation. It's an inequality. So when you cancel the minus sign on, there are many rules of inequality. This is one of it. So when you cancel the minus on both the sides, the inequality should be reversed. The inequality should be reversed. Now it's true. When you take off the signs, that is when you multiply both the signs, both the sides of the minus sign. You're multiplying both the sides of the inequality with a minus sign. Or in simple words, you're changing the signs on both the sides. When you change the signs on both the sides, the inequality is reversed. So when you cancel minus on both the sides, greater than becomes less than. So 4 is less than 10. Yeah, it's true. In the same way, here when I change the signs on both the sides, minus B by 2A becomes plus B by 2A. And 0 is neither positive or negative. It's just 0. But I've changed the signs on both the sides. So the inequality is reversed. B by 2A is less than 0. B by 2A will be less than 0 because I've changed the signs on both the sides. Now, how do we? I'll just put this back in your mind. We were saying that minus B by 2A lies in the first quadrant. So this thing is positive. Changing the signs on both the sides like this. Now, what is A? A is positive or negative? A is negative. A is negative. Now, when will this whole thing be negative? See, B by 2A is less than 0. That means it's negative. B by 2A is negative. When will the whole thing be negative? When will B by 2A be negative? If supposing 2 is a constant, so leave 2. So it all depends on the values of B and A. Now, A we know is negative. A is negative. Now, if B is also negative, minus and minus will get cancelled and it will be positive. But B by 2A should be negative. B by 2A is less than 0. B by 2A should be negative. So this can be negative only when B and A have opposite signs. Because if B and A have same signs, both plus or both minus sign, okay, if A and B, both of them have plus or minus signs, the final result is positive. So here B by 2A, the value of B by 2A should be negative. Now 2 cannot decide that because 2 is a constant, 2 is only 2. 2 cannot decide that. Only B and A can decide that. The values of B and A can decide that. And we already know that A is negative. And we also know that if this whole thing has to be negative, B and A should carry opposite signs. So since A is negative, B has to be positive. Since A is negative, B has to be positive. So that's what is, you can see it. B is positive. B is greater than 0. B is greater than 0. That's what I've written here. Since A is negative, B is positive. That's all it is. Everywhere we have to just write that. Because we know if, the whole thing has to be negative, A and B both cannot carry the same sign. They have to carry opposite signs. Now A already we know carries a negative sign. Then B should carry a positive sign. Only then the whole thing can be negative. Let's do it once again before we proceed. So this one is easy. This is easy. It opens downwards. So A is negative. A is less than 0. Now minus B by 2A lies in the first quadrant. So it is positive. Changing signs on both the sides, you will have to change the inequality also. When you take away this minus sign, you're changing the signs on both the sides. You'll have to reverse the inequality. Now this one means that this one is negative. B by 2A is negative. Now this can be negative only if B and A carry opposite signs. A is negative. A is negative. So B has to be positive because opposite signs. A is negative, so B should be positive. Only then the whole thing can be negative. So since A is negative, B has to be positive. Writing that in words is the same as this inequality. And you should use inequalities. Just say it in your mind, using the terms positive and negative. But while writing, you use less than 0, greater than 0. You say positive, negative in your mind. But while writing, don't write those words. Just use the inequalities less than 0 or greater than 0. So that's how we get the value of, we determine the sign for B. Just a minute, children. Just a minute. Thank you, children. All right. So now we're done with A and B. Now coming to C. So C we can find from this point P, which lies on OY. Again, this point P can lie on OY or OY dash. OY is the positive side of the y-axis. OY dash is the negative side of the y-axis. OY is the positive side of the y-axis. OY dash is the negative side of the y-axis. So the parabola can intersect the y-axis on its positive side or the negative side. Now here it is here. Here it is here, meaning here P lies on OY. Here P lies on OY, the positive side of the y-axis. Now, now you'll be like, why should you do that? But we'll just wait and see what happens. Now, here we know that for meaning the value of y can be anything, but x is 0 because it's the y-axis. On the y-axis, x is always 0. Like if you want to mark the coordinates of this point, this one will be 0, 1. This will be 0, 2. I don't know if it is 0, 3, but like that. So 0, 4. So on the y-axis, x is always 0. Now we'll do one thing. We'll just use x0 and find the value of y. So like this, you can, when you have the the quadratic polynomial in this form, you can find where the parabola will cut the y-axis. When you take x as 0 and find the corresponding value of y, you can find out where the parabola cuts the y-axis. So that's what we're trying to do now. We're trying to understand where the parabola cuts the y-axis, but we cannot find because it is ax squared plus bx plus c. So you cannot really find out where, but you will try to understand something out of that. So after this, we finished till here. Now see here, P lies on OY, not OY dash. P lies on OY. So the coordinates of P, 0, y. 0, y. Even if it is OY dash, it is 0, y only. It's 0, y only. Even if it is that, we don't say 0, minus y. That's not the way we say. It's 0, y only. Okay. So this one is 0, y. Okay. Now y is equal to ax squared plus bx plus c. All right. Y is equal to ax squared plus bx plus c. Now when x is 0, why x is 0? See here, x is 0. When x is 0, what is y? Y is equal to c. And that's, we want to judge the sign y carries. Okay, we want to judge correctly. Okay, not like judging people. Okay, we judge people maybe incorrectly also. So here we need to judge it correctly. So this one will help you to judge the value of c. So when you give x0, you get y is equal to c. Y is equal to c. What is y? Okay, what is y? See, this is y. C is equal to y, and we have y here. C is nothing but y. C value is nothing but y value. C value is nothing but y value. We don't know the value of y. We don't know the value of y, but we know y lies here. And what is this? It's the positive side of the y-axis. So since y is positive, c is positive. So we are judging. So we are finding the value. Y carries. Now you will say, then you can say directly, why did you work all this? We didn't know that y is equal to c, right? We didn't know that y is equal to c. Only when we work this. So now you know. Every time you substitute x0, you will get y is equal to c only. That we realize only now. So for that you have to work. Before working this, we were not aware that y is equal to c. So every time you give x0, you will get y is c. So c is equal to y. So c is equal to y, meaning where is y? Y is here. What is it? 0, y. 0, y. Y is here. And what is y here? It is positive. It's a positive side of the y-axis. So y is positive. That means c is also positive. That's what is here. Instead of writing y is positive, since y is greater than 0, y is positive. Y is greater than 0. C is also greater than 0. Hence, these are the values, or these are the signs, not values, I'm sorry. So these are the signs carried by A, B, and C. These are the signs carried by A, B, and C. So A, easy, upwards, downwards, upwards positive, downwards negative. B, you should use this one. For B, you should use this one. Right, this one, because it lies in the first quadrant, it's positive. Change the signs on both the sides, so the inequality is reversed. Now, if this has to be negative, if this whole thing has to be negative, B and A should carry opposite signs. A is negative, so B has to be positive. B is positive. And in C, if we find from this, we find from the coordinates of P. So give x is equal to 0 and show that y is equal to C. And since y lies on the positive direction of the y-axis, y is positive and hence C is positive. So this one, children, it's difficult to concentrate if I go on. So I have 6 slides like this. I'm sure it's difficult. See, then what will happen at a point is like, you'll only listen positive, negative. You really cannot comprehend. You really cannot comprehend if I go on. So we'll do, maybe remind me, next class we'll try to do, next class we can do a little faster. Because now that you know how we, determine the signs, I can also do it faster. Now I don't think it will be effective. I'm only scared if it will be effective or not. Maybe I'll just do this one. The others I'll just share the images. Go through that. And the next class we can, I said I have 6, right? Yeah. So 1, 2 we'll do now. Remaining 4, all the 6 I'll share on WhatsApp. Revise, and next class just remind me. We'll, quickly go through the remaining 4. So here you can see the vertex lies in the 4th quadrant. And in the 4th quadrant also x coordinate is positive. Also I'm saying because we just saw positive. So that's why I said also. So in the 4th quadrant, the x coordinate is positive while the y coordinate is negative. The vertex, you can see in this graph, you can see that the vertex A lies in the 4th quadrant. And in the 4th quadrant, the x coordinate is always positive. The y coordinate is always negative. Now, minus b by 2a, minus b by 2a. Why we have written minus 2, b by 2a is greater than 0? Because it lies in the 4th quadrant and because the x coordinate in the 4th quadrant is always positive. A upwards, so greater than 0. Change the signs on both the sides here, so you get this. So B should be negative. I'm sorry, this one, the whole thing should be negative. This whole thing should be negative. This whole thing should be negative. That means B and A should carry opposite signs. A is positive, so B should be negative. Now P lies on OY dash. P lies on OY dash. It lies on the negative side of the y-axis. It lies on OY dash. However, this is the standard way of writing. The coordinates are 0, y. Y is negative, but y is negative. The y value will be negative. The y value will be negative because here we mark -1, -2, -3, -4. So y value will be negative. Okay. So now when x is 0, so same working, when x is equal to 0, you get y is equal to c. Y is equal to c. So whatever is the sign carried by y, the same will be the sign carried by c. And y is here. This is only 0, y. This is 0, y. This is 0, y. And y is negative. So c is also negative. See, y is negative, less than 0. So c is also negative. So a greater than 0, b less than 0, c less than 0. This, in the same way, you can understand the others. Yeah, I think I'll just show the images. You can take screenshots now. Yeah, please do that, children. I might forget to share the images. Now that you can take a screenshot, please do that now. This is the first one. Second. Done, children? Okay. Third.
Done, ma'am.
Yeah. Fourth.
Done, ma'am.
Yeah. 5.
Done, ma'am.
Yeah. 6.
Yes, ma'am.
All the children. So if you have not deleted the chats on WhatsApp, you can find this. This one has 6 questions, 6 case study based questions. So these questions only Danya had worked the assignment and shared the answers on WhatsApp with me. You were supposed to complete this and share the answers on WhatsApp with me, but I remember Danya was the only student who had done this. Navya, you were not there at that time, so it's not you included here. So Danya, you remember you had answered, you tried your best with all this and you shared the images. You remember that? Yeah.
Yes, ma'am.
Yeah. I'm sorry, Danya. So I'm too late in showing you the answers. Yes, class. So so you can see the description given regarding the automobile manufacturing unit. An automobile manufacturer can produce up to 300 cars per day. Okay, can produce up to 300 cars per day. The profit made from the sale of these vehicles. The profit made from the sale of these vehicles can be modeled by the function P of x is equal to, you can see that minus x squared plus 350x minus 6,600, where this is important. You need to understand what this equation is trying to convey, or what you can find when you give values for x. What does that value of x represent? And when you give the value of x and find the value, what does that represent in this practical situation? What does it mean? So is what we have to understand. So you need to read the case study. You cannot answer the questions if you don't understand the case study. So now we have this function P of x is equal to minus x squared plus 350x minus 6,600. Now what is this going to, okay, fine, this is a quadratic polynomial, but what is it going to give me? What is meant when I give a value of x? What is that value of x? And when I find the value, upon finding the value, what does that value imply? What does it mean to me? Or what does it mean to the situation? That you need to understand. Only then you can answer the questions correctly. So where P of x is the profit, P of x represents the profit in 1,000 rupees. The profit in 1,000 rupees. And x is the number of automobiles made and sold. So x, if it's given x is 10, or if they say 10 automobiles were manufactured today, that means x is 10. Or if on a particular day, 10 automobiles were manufactured, that means x is 10. Why x is 10? Because x represents, in this polynomial, x represents the number of automobiles made and sold. So automobiles made and sold is given by this variable x. And when you give different values of x in this polynomial, you get some value, right? What is that? That is the profit made in 1,000 rupees. That is, if you get the answer as 50, it is 50,000. If you x, when the value of x is the number of automobiles manufactured, when you give some value of x and find P of x, supposing you get 50, it's not 50, 50,000. Add 3 zeros, because 1,000 is 3 zeros, right? So 50, if you get 50, 50,000 it is. If they say is the profit in lakhs of rupees, then add 5 zeros. If you get 50, add 5 zeros. 50 lakhs is the profit. Okay. Now answer the following questions based on this model. When no cars are produced. Okay, so now this, when you make the graph of this polynomial, this quadratic polynomial, A is negative, A is -1. So it will open downwards. It will open downwards. It will open downwards. Okay, it will be like this. And okay, 1 minute. Let me do it one by one. Yeah, it will open downwards because A is negative. Now, when no cars are manufactured. Now, remember in any business unit, now we'll not go to the details today. I'll just tell you what is needed for you. Okay, so in any business, there is some expenditure. Even if you don't manufacture cars on a particular day, you will have to, there will be some expenditure, maybe electricity, your employees' traveling expenses, or maybe the people who clean up the site, the business place. So every day, whether you make business or you don't make business, you have some fixed expenses. See, for a particular month, supposing you don't, the automobile manufacturer, he does not manufacture cars. Okay, so he's say out of the country. So that particular month, for some reason, no cars are manufactured, no vehicle is manufactured. But he'll still incur some expenditure. There is still some expenditure incurred. He cannot tell his employees that, okay, this month no, production, so no salary for all of you. That's not possible, right? So there are some fixed expenses which every business has to meet out, whether irrespective of producing, not producing, profit or loss. Okay, so that's what it is. So when no cars are produced, what is the profit or loss? So it's not that, okay, no cars are produced, straight away you can answer what a question is this. When no cars are produced, there is no profit or no loss. So you cannot write there's no car produced, so there is no profit or loss. It's not like that. When no cars are produced, what is the profit or loss? So what is the value of X? 0. Why X is 0? Because X represents the number of automobiles made and sold. So when no cars are produced, the value of X is 0. So you must substitute this in the function. You must substitute X 0. So wherever there is X, say 0. Wherever there is X, say 0. And find P of 0. And find P of 0. It's minus 6,600. It's minus 6,600. So it is actually 6,600. Second. Yeah. 1 second, children. Yeah. So you can see that even when no cars are manufactured, there is a loss. That's why you're getting a negative value. You cannot get a positive value here. You cannot get a positive value here. So you're getting a negative value. Why is it negative? Because as we said, there will be some fixed expenditure. Irrespective of making, not making cars, there will be some expenditure. So when no cars are produced, the loss incurred is rupees 1,000 rupees. I forgot to write that. This is in thousands. The profit or the loss will be in 1,000. P of X represents the profit or loss in thousands of rupees. So in thousands it is. I'll change this presentation later, but now you understand what I'm saying. So the loss incurred is so many thousands, even if no cars are produced. Next one. Yeah, the question is here. It's one case study only. It's one case study, one case study has 3 or 4 subdivisions, and sometimes you have an internal choice between maybe the second or the third subdivision. There's an internal choice. You can answer this or that. Yeah, so it's the same case study, children. I put the different subdivisions and different presentations, meaning in different slides. Yeah, the second one is, what is a break-even point? What is the break-even point? So break-even point is where the business does not make any profit or loss. No profit, no loss. You have manufactured and sold something. You've manufactured and sold, but that's the no profit, no loss, point. So that's the break-even point. So break-even point is a point where there is no profit made or no loss incurred. So basically, profit or loss is equal to 0. So now what represents profit or loss? What represents profit or loss? P of X. That's what is defined in the question. P of X is the profit in 1,000 rupees. P of X. So when they say break-even point, the profit or the loss is 0. No profit, no loss. What's your profit? 0. What's your loss? No, nothing. No loss, 0. What's your profit? Nothing, 0. So whether it is profit or loss, it is 0. That means this one is the profit, right? This one is what represents the profit or loss. This one is 0. This one, not X. When you take X as 0, X represents the number of automobiles manufactured and sold. So when you take X as 0, it's a number of automobiles manufactured. So in the first one, no cars are produced. So X is 0. In the second one, X is not 0. P of X itself is 0. P of X represents the profit. That profit itself is 0. So P of X is 0. If P of X is 0, it means this one is 0. This one is only P of X. Who is P of X? This one is P of X. P of X is 0 means this one is 0. This one is 0. Which means you will have to solve the quadratic equation. You'll have to solve the quadratic equation. So on solving the quadratic equation, you get x20, x330. That means the graph of this x is 20, x is 330. The parabola, it opens downwards because a is negative, and it intersects the x-axis at 20. This point is 20. This one is 330. Okay, because x is 20 and x is 330. That means the parabola cuts the x-axis. The parabola cuts the x-axis at 20, the marking 20 and the marking 330. And clearly here, what will be the coordinate of this point? It will be 20, 0. The y value is 0. And here it will be 330, 0. 330, 0. And the profit is what is represented along the y-axis. When we say P of X, it's the y value. It's the y value. Y is equal to. That's what is P of X. P of X meaning y is equal to. When you give some value for x, you get the corresponding value for y. So P of X is, the function is defined like this, which is nothing but the value of y. Now see here, when x is 20, that is when 20 cars are manufactured, y is 0. That means the profit is 0. Also, when 330 cars are manufactured, y is 0. That means the profit is 0 or the loss is 0. Because these points lie on the x-axis. These points, they lie on the x is 20, x is 330. The parabola intersects the x-axis at these 2 points, 20 and 330. The coordinates 20, 0, 330, 0. So when x is 20, y is 0. When x is 20, meaning when the number of vehicles manufactured is 20, y is 0, meaning profit loss 0, no profit. Similarly, when they produce and sell 330 vehicles, again the profit and loss is 0. So at these 2 points, the company sees the break-even point. So between this, so if the company has to make a profit, it should manufacture vehicles between this range. It should manufacture vehicles between this range. So anything manufactured, any number of vehicles manufactured more than 20 and less than 330, there will be a profit. So you can see the rising graph also. You can see the rising graph. So there is some profit made because you will get some value for Y, no? Some value you will get for Y. So that's the profit. You can see the rising graph. So this is the peak. Maximum profit is got at the vertex. The vertex of the parabola represents the maximum profit the company can make by selling this many vehicles. By selling this many vehicles. The vertex of the parabola, the coordinates of the vertex will tell you the maximum profit made and the number of vehicles to be manufactured. The vertex of the parabola will tell you, the x-coordinate of the vertex will tell you how many automobiles have to be manufactured to get that maximum profit, which is given by the y-coordinate. Vertex is a point. A point has an x-coordinate and y-coordinate. The x-coordinate is the number of automobiles made and sold. So if the company makes that many automobiles, the profit is maximum because at the highest point in the parabola, the profit is maximum. That's given by the y-coordinate, whatever is the value of y. X-coordinate will represent the number of vehicles to be made and sold. The y-coordinate will represent the profit. So that's why we have to remember the coordinates of the vertex of the parabola. If a question is, I think we have it in this question itself. No, not here. Okay. All right. So the second question was, what is the break-even point? Break-even point is when this one is 0. When this one is 0, the profit is 0. Profit is 0 meaning this one is 0. This one is 0 meaning you'll have to solve the quadratic equation, find the two values of x. I've used the quadratic formula. So from these values, you understand that the parabola cuts the x-axis at 20 and 330. So when the break-even point is 20 cars or 330 cars. When the company produces 20 cars or 330 cars, no profit, no loss. What is the profit and loss if 175 cars are produced? We understood that actually. We said anything between 20 and 330. Anything between 20 and 330. Any number of cars produced between 20 and 330, there will be some profit. May not be maximum profit. We don't know. We can calculate and say. Just looking at the number, we cannot say. So anything between any number of automobiles manufactured between 20 and 330, there will be some profit. There will be some profit. Some profit. So now 175 cars are produced. So 175 cars are produced is the X value. X represents the number of automobiles made and sold. X is 175. When X is 175, find. So wherever there is X, put 175. Wherever there is X. So here you will have to be careful while calculating. You should not take this as minus 175 the whole square. It's not minus 175 the whole square. Wherever there is X, use 175. There is minus 175 and square. 175 should be squared. And then put a minus sign. See, you can see from this. Minus x squared is different from minus x the whole square. Yeah. So this minus sign you can see here. Minus sign. Dileepan, I just noticed that. Are you trying to say something, Dileepan?
No.
No. Yes or no?
No.
Okay. All right. So what was it saying? Yeah, I was telling you about this one. So be careful while calculating this. 175 has to be squared. 175 has to be squared, not minus. It's not minus 175 the whole square. So you get this one. So many thousands of rupees, children. Not this one, children. So many thousands of rupees. That's a mistake. I forgot to type that. I didn't realize it actually while typing. I just realized. So when I was like working the answer, probably I didn't realize. I made it sometime back. I don't know. So it's all in thousands of rupees. It's explained here. P of X is the profit in 1,000 rupees. So many thousands. You just put thousands after this. That's all. You don't even have to put the zeros. Just put thousands. So many thousands. Okay. So when 175 cars are produced, the profit made is 24,000, 24025 thousands. 24,000, 25 thousands of rupees. That's the profit made. Made, not more, made. Okay. And then what is the profit of see this is 3, this is 3, this is also 3. It's not a mistake. It's the internal choice. You can answer this one or this one. It's internal choice. So that's why it's 3 here and it's 3 here also. So what is the profit if 400 cars are produced? Now, since we have found the break-even point, we know the break-even point. So we know that, anything less than 20 or anything less than 20, anything more than 330. Okay, 1 minute. Let me not talk like that. Show like this. So cars manufactured between this only, there will be profit. So if you manufacture beyond this, it will be a loss. That's what is given by this equation. You can see here. 22. If the company wants to make a profit, it has to manufacture anything more than 20, but less than 330. If it manufactures exactly 20 or exactly 330, no profit, no loss. Exactly 20, exactly 330, no profit, no loss. If the company wants profit, any number of vehicles more than 20, but less than 330 should be manufactured. But here they're asking us to find the profit if the number of vehicles manufactured is 400. So it's clearly a loss. It's a loss. Yeah. So you can see that. So when so many cars are produced, so X is 400. So when X is 400, put 400 everywhere. Everywhere put 400. And you get this one. So many thousands is the loss. So many thousands is the loss. Got that, children? Yeah. Any questions?
No, ma'am.
Okay.
No, ma'am.
I'll let you know. Yeah. I'll just take up one where, we have that I was telling you, this one. Yeah, we'll do this one so that I can explain something different. Yeah, we'll do this one. Yeah. Yeah, we'll do this and wind up the session for today. So you can see the case study, maximum profit. A kitchen utensils manufacturer can produce up to 200 utensils per day. He can produce up to 200 utensils per day. Okay. The profit made from the sale of these utensils can be modeled by the function P of X is equal to whatever you see there, where it's actually 3,300. I forgot to make the change. It's modeled by this function. What do you see here? It's 3,300 children. See here. 1,300. Okay. So P of X is given by that quadratic polynomial, where P of X, that's important. That is what is important. What to understand from this function? P of X is the profit in rupees. P of X is just a profit in rupees. So whatever you get, that is a profit. No 1,000, 100 rupees or thousands of rupees, whatever. And X is the number of utensils made and sold. Okay. So we need to answer the questions based on this information. Find the y-intercept and explain what it means in this context. Find the y-intercept. So y-intercept is that point where the parabola intersects the y-axis, where it cuts the y-axis. Y-intercept is the point where the parabola intersects the y-axis. Now this one you can see is negative, so it opens downwards. It opens downwards. So okay, so this one. This is the y-intercept. This one is the y-intercept. The parabola will cut the x. See, x-intercept, you will have two different points. For x, you will have two points. The x-intercept, because the parabola will cut the x-axis. X-axis at two distinct points. So for x, you will have two values. Now y, it will cut the y-axis at one point, and that's the y-intercept. So you need to find the y-intercept. So we know that where the parabola cuts the y-axis, the x-coordinate will be 0. The x-coordinate will be 0. So the coordinates of the y-intercept are 0, y. 0, y. Because where the parabola cuts the y-axis, the x value will be 0. So find when x is 0. So when x is 0 meaning wherever there is x, use 0. Wherever there is x, use 0. And find the value. Minus 3,300. Minus 3,300. So that means this point is 0, minus 3,300. This point is 0, minus 3,300. Okay, but what does it mean in this context? What does it mean in this context? That means, see here, because when you make the graph along the x-axis, you will be showing the number of utensils made and sold. Because we always define the x-axis and y-axis, right? So the x-axis, along the x-axis, it is the number of utensils made and sold. Along the y-axis, we will get the corresponding profit or loss. On the positive side of the y-axis, it's the profit. Negative side of the y-axis, it's loss. So when no utensils are manufactured, because the x-coordinate is 0, the x-coordinate represents how many utensils are made and sold. The y-coordinate represents the profit or loss made. It's a profit if the y-coordinate is positive. It's a loss when the y-coordinate is negative. So I'll read the question again for you. Find the y-intercept. Y-intercept is the point where the parabola cuts the y-axis. And where it cuts the y-axis, the coordinates will be 0, y. So when x is 0, 0, y, no? So in 0, y, x is 0. So when x is 0, y is minus 3,300. This is why I told you, children. See, I told you this one when we started. I told you there's nothing but y. This function P of X is nothing but y is equal to. P of X is equal to meaning y is equal to. The y value is equal to. So when you find P of 0, you're finding the value of y only. Y is minus 3,300. So that means when X is 0, when no utensils are manufactured, are made and sold, the loss incurred is the Y coordinate minus 3,000. The loss is 3,300. The value is negative. It's a loss of 3,300. When X is 0, Y is minus 3,300. So X coordinate represents the number of utensils manufactured, made and sold. 0, nothing is made and sold. The Y coordinate is a loss because it's negative. That's the first one. That's what is y-intercept, and that's what is understood by the coordinates of the y-intercept. Find the x-intercept. So find the x-intercept meaning where the parabola cuts the x-axis. And explain what they mean in this context. So the coordinates. So the coordinates of the x-intercept are x, 0. You know that. Where it intersects the x-axis, x, 0. That is y is 0. Y is 0. On the x-axis, y is 0. So y is 0 meaning this one is 0. P of x is 0. This is only y. Y is 0 meaning P of x is 0. And P of x is 0 meaning this one is 0. X-intercept is are the points where the parabola cuts the x-axis. On the x-axis, the points look like x, 0. So when y is 0 means P of x is 0. P of x is 0 means this one is 0. So when this one is 0, meaning you'll have to solve the quadratic equation using the quadratic formula. Solve it. You cannot, it's difficult to split the middle term or factorize. So the quadratic formula, solve it, we get 20 or 330. 20 or 330. All right. So that means when the number of utensils produced is 20, the question is find the x-intercept. We found the x-intercept. The parabola cuts the x-axis at the point 20 and 330. So when the so what does it mean in this context? So when the number of utensils produced, per day is 20, there is no profit because y value is 0. Y value is 0. Okay. Or when the number of utensils produced is 330, there is no profit made or loss incurred. Break-even point. That's the break-even point. This is the x-intercept. This is also the x-intercept. The point where the parabola cuts the x-axis. The coordinates 20, 0, 330, 0, 330, 0 coordinates. So x coordinate is how many utensils are produced. 20 utensils are produced. Y coordinate tells us the profit or the loss incurred. No profit, no loss, 0. Again, 330, number of utensils produced and sold. 330. Only if you sell, the transaction is only when you sell. You produce and have it yourself, no profit, no loss. You have to make and sell. So when 330 units are made and sold, no profit, no loss, because the y coordinate is 0. The y coordinate is 0. So anything between this, if the company makes and sells, it'll be a profit. So that's the meaning. That's the meaning. Next one. I told you, same case study. The third subdivision is how many utensils should be sold to maximize profit. So this is where we use the the coordinates of the vertex of the parabola. This is when we use the coordinates of the vertex of the parabola. The coordinates of the vertex of the parabola are given by minus b by 2a, comma minus d by 4a, where minus b by 2a is the x coordinate and minus d by 4a is the y coordinate. The x coordinate represents the number of utensils made and sold. The y coordinate represents the profit made. And the vertex is the highest point. So the y coordinate is the highest profit made. Highest point. The maximum value of y, this one. See here, the value of y is lesser. Value of y is lesser. This is the maximum point of, this is the maximum value of y. Then so many vessels should be produced. If this many vessels are produced, then the company can make maximum profit. So minus b by 2a represents how many vessels should be made, x coordinate. Minus d by 4a represents the maximum profit made. If you find the x, if you find minus b by 2a, you will get the x value. That is how many utensils should be produced to maximize the profit. If you find minus d by 4a, you will find that maximum profit. What is that maximum profit that can be made? That you will find using minus d by 4a. Now to answer this question, we have to find minus b by 2a, because how many utensils? So that is the x coordinate, that is the x-axis. How many utensils should be sold to maximize profit? So we should find x. So that is the x coordinate minus b by 2a. So simply find minus b by 2a, that's all. Just find minus b by 2a. You know how to find the values of a, b, c, right? A is this one. A is minus 0.5, b is plus 175, and c is minus 330. So find minus b by 2a. Minus b by 2a and yeah, 175. So 175 utensils should be sold. 175 utensils should be sold to maximize profit. And here, maximum profit. What should be the maximum profit? Sorry, what is the maximum profit? Maximum profit. That's given by minus d by 4a. So find minus d by 4a, that's all. Simply find minus d by 4a. Minus d meaning minus b square minus 4ac. See, that's what calculations is simple, but you can go wrong. So minus d. So see here, minus d in bracket. Minus d, this is d. What is in bracket is d. Minus d, put a minus outside. Don't write minus d like this. Minus d is b square minus 4ac. You're wrong. Minus and d is b square minus 4ac. This is wrong. D is b square minus 4ac. And negative of this one, like this, by 4a. So substitute the values and you get this. So this is the maximum profit. This is not hundreds of rupees or thousands of rupees. This is only the profit. This is the profit. Class, use the emoji, raise your hand. So Prajit, Madhumita, Shri Krishmi, Danya, Rakshita, Navya, Kirtana, Raja, Shri Ranjan and Arjun. So Florentina, I think about 4 to 5. How many missing? Ritika and Raghavi have not been attending the classes recently. Sashank told me that he's on a tour and Florentina is not there. All your children. Any questions, children?
No, ma'am.
All right. All right, children. So I'll just share these two, answers on WhatsApp. I think it will help me if you can just stay back and take screenshots, children, just in case I forget to send, can all of you do that? Just give me 5 more minutes. You can take the picture so that you will complete this by the next class. Just stop the recording and show you.